Uh, Good evening, everyone. My name is Otimong Jonathan, and I would like to welcome you back to my YouTube channel. So, I will be discussing with you our way forward through deployment and the business pitch of our project. Our hybrid AI agricultural cost predictor will be deployed on railway, and it will be deployed through railway on GitHub. So, I'll be taking you through these brief slides and explain where necessary. So we shall basically start from the problem space and purpose. What is the objective of this model? So the objective is to reduce the pre-production financial risk in smallholder farming uh, by creating a hybrid AI model that basically accurately predicts the forecasted total input cost, which is an aggregate of what? Of the individual input costs that we are supposed to use in our what in our investment process during our agricultural what planting. So what is the core problem? So the core problem is mainly the fundamental market failure in agricultural information, according to smallholder farmers. So smallholder farmers face a high stake investment decision committing by committing their capital without reliable information on the basic inputs that are required in the agricultural process, the investment risks, and potential fluctuations in market prices and all that. So the model will basically help farmers solve this. So the current estimation methods are static and ignore critical variables like local market volatility, soil-specific input needs, and forecasted labor costs. So our model will have to consider all this so as to give a more robust and a more improved um, prediction and forecast of our total input costs. So who experiences it most? So the primary people who experience these are smallholder farmers who are basically involved in plantation agriculture of less than 2 acres. So as you all know, such farmers don't have access to reliable information, reliable tools that can help them in forecasting fluctuating agricultural prices of different inputs. So the model will help them do this. So the other users who are there are secondary stakeholders, for example, the government, external resource workers, for example, these external officers who studied agriculture, so they help farmers in advising them, financial institutions who face high default rates on agricultural loans due to cost planning. So agricultural businesses and governments struggle with productivity goals as farmers risk aversion that prevents adoption of improved and higher input costs. So our AI is a very essential need because it fuses predictive analysis using the GRU with symbolic reasoning using knowledge graphs, um, with symbolic reasoning using knowledge graphs to create a dynamic financial model that will help farmers reduce risks of what? Of financial loss. So the measurable impacts are economic. The economic impacts for farmers, there is a reduction in incidence of mid-season abandonment and debt providing, which is a no-go decision. So the social impact will be farmers have shifted. Some farmers will shift from guesswork to evidence-based financial planning, and also food security, preventing crop failures caused by running out of funds for inputs. There is also increased percentage of farmers operating within their own budgets. So the users, the stakeholders, and the ecosystem actors. So the primary users, as I said, are smallholder farmers. So how will they access the system? They will access it using mobile devices, USSD, through the internet. Also, they can also access that and receive what desired forecast. So the secondary stakeholders are basically the what The secondary stakeholders are basically the banks, the microfinancial institutions, the government, and all those. So those are the people who provide external services to the farmers. So these are people. How will they access and how will they use this? They will help farmers by educating them, by providing valuable insights about agricultural resources. They provide market insights about all that, about input suppliers, and also distributors will also provide more information to farmers to help what make the model more realistic. So ecosystem roles, these are the operational enablers, like the data suppliers, like the government agencies who provide open data calendars, soil maps, and official price bulletins in, for example, newspapers, radio stations, TV stations, and all that. So government governance entities, compliance and reliability, internal AI ethic board ensuring model fairness, which prevents bias against certain farm sizes or regions. There is also data privacy and algorithmic transparency. Agricultural universities are also some of the stakeholders, and research institutes that are mainly focused on agricultural resources and all that. So, we shall now proceed to the data sources and the value. So, the objective is to construct a robust multimodal data backbone that fuels our hybrid model, ensuring accuracy, ethical integrity for creating tangible user value. So, the data types that are involved there, for example, include structured data types which are tabular. This is historical input prices, soil test results, and crop yield data. So the primary sources, supplier price lists, which are, for example, listed in FAO, the cooperatives, the government bulletins, and all that. So the text, government advisory reports, research papers on crop inputs, for example, those provided by UBOS, Agriculture Organization, World Bank, and all that, the Ministry of Agriculture, and all that. So this is mainly provided by such sources. So the processing pipeline workflow, which is the workflow for data quality and model readiness. This is the collection. So automated APIs for prices, manual uploads for historical data sets, and the user inputs. So how did we clean the data? Cleaning was mainly done by handling the missing values, correcting entry errors, and also removing the non useful columns. Then annotation and feature engineering, labeling growth, enriching price data, and all that. So validation, how did we validate? By cross-referencing data points across multiple sources. Then storage, we stored on secure cloud databases. For example, we secured on what? On Cargo. Shall now proceed to solution and AI what? System description. So the objective is to deploy a hybrid AI model that transforms raw agricultural input data into actionable, personalized investment insights for smallholder farmers. The AI core methods and algorithms, temporal forecasting, which is done by the GRU, will capture the complex nonlinear patterns in historical price and for accurate input cost forecasting. Then the knowledge graph reasoning will encode the agronomic rules to determine the input quantities and to find the alternatives. Then we shall proceed to the model inputs and outputs. So the farmer will get a query that will request them to enter their the crop they desire to invest in, to enter their region and the district or an approximate district to them, because not all districts are listed. So the historical and real-time prices as external data as inputs and granular cost breakdown. So total projected investment, capital adequacy as outputs. So those will be our outputs. So integration workflow, mobile fast app, which will be deployed on railway, then USSD, which is the SMS gateway that reaches farmers without what? Smartphones. Responsible AI mechanism, explainability, pie charts, cost breakdowns, and simple why explanations for recommendations with also frequently asked questions. Bias control, regular fairness audits to ensure models perform equally well for different farm sizes and regions. Key metrics and evaluation. The key metrics are technical metrics, which will involve the performance metrics that are R squared, the MAP, the RMAP, then user-centric metrics, which is the adoption rate target, which is at least more than 60%, the ethical metrics, the business metrics, uh, and then we shall proceed to unfair advantage and differentiation. So the objective is to establish a defensible competitive edge through unique assets and self-improving systems, proprietary and defensible assets. The hybrid core that integrates the GRU temporal model and the agricultural knowledge graph, exclusive data sharing agreements with national farmer cooperatives and input suppliers for strategic partnerships. Then self-reinforcing feedback loops, farmer usage improving knowledge graph with real world input application data, more users will with better data, more accurate predictions, and more what? User trust and adoption. Actual validation retaining GRU models for better future forecasts. Sustainable long term differentiation. Adaptive AI, which our models are designed for continuous learning from new seasonal data, which will also enable us to scale to a larger platform later on. Then channel and distribution. How will farmers access this? How will they discover this? This is acquisition channels, sensitizations and campaigns through radio stations, televisions, newspapers, and all that. Then delivery channels, mobile apps, also offline SMS and USSD. In partnerships, shall partner with our local agricultural external officers, the NGOs, the Ministry of Agriculture, and all that. Then the retention tactics, continuous updates, what if scenario simulations, tactical modern ways to farm cheap and yield full uh, returns. Then revenue streams, there's direct approach, which shall basically require regular subscriptions, institution-based licensing fees, and pay per use APIs. So there's also indirect approach, data which will mainly use data as a service, which will involve collaborations, partnerships, especially with input suppliers and demanding companies. Then free to premium. This is mainly whereby you first register people as free users, and then they will be required to what? To continue to premium if they want to continue using the service. Then sponsored research on product from various institutions globally. Key resources, human resources, AI engineers, the machine learning researchers, the data scientists, the user experience and user interface designers, the farmers and their action needs for the system policy experts and digital security experts. Then technical um, infrastructure, railway cloud services, crane cloud services, and machine operations tools like especially Docker. Then data infrastructure, cargo notebooks to clean and set data, which is the EDA, VS Code to sample and test, GitHub to join and collaborate together to form a more functioning and robust system. Then organizational resources, Mercury AI Lab, and all that. Then we shall proceed to key activities, that is model lifecycle management, continuous data acquisition and validation from diverse real-time resources, active learning and retraining pipeline to combat model and data drift seasonally. Then product and platform development, feature engineering, for example, improving the features, adding in more data, making it more realistic for mobile, fast, and USSD. User experience design for maximum accessibility and adoption. API development and integration with data providers and the financial systems that provide farmers with loans. Then operational excellence, there is also governance and compliance, which is a quarterly bias and fairness audits to ensure that the model does demographics and transparency reporting, which will improve its performance. Then the key partners are technology partners. Then we have some data and research partners, for example, Ministry of Agriculture, FAO, and yeah, Uganda Bureau of Statistics. Then ethics and governance, data protection authorities, for example, POPS, And then distribution and commercialization. Microfinancial institutions will also be under this to integrate capital adequacy checks into loan approval processes. The next one is cost structure. So sponsored, most of the work was fully funded by Makerere University, and also we had some support from Unipod, then some full-time commitment from my group members, and then some open tools like Kaggle, different research books, for example, these things about Turing test and all that. Then governance ethics and compliance, governance model. How well does it suit the nation and follow the laws does, like for example NEMA checks out and environmental friendly activities advice, and NCDC for certified quality suggestions, and local agricultural officers for advices, regional best way forwards, environmental friendly, evidence based guidance and description holdings. Scalability and sustainability. The model will actually be sustainable, and it will be deployed on Railway and GitHub services. Updates and improved learning. This will be done by continuous learning by providing new data and new different contextual factors that will help improve the model functionality. Localization. There is also finances, paid packages that for example, data as a service, partnerships for research, as well as government collaborations with grants and donations. Then environmental advantage advises on only on nature favorable options and certified inputs for long run builds, trust advices like crop rotation and land rest and all that. Then intellectual property. Uh, the hybrid pipeline graph attention network, the robust network, and the Monte Carlo all in one with what if scenarios, the capital adequacy checkouts, and the frequently asked questions. There's also mobile and SMS well joined integration for the smallholder best piece with offline workouts and evidence what best outputs. Then these are our team contributions to the project. And then I would like to thank you for that. And therefore, I will stop here for today. We shall proceed when time comes. Thank you for listening and thank you for watching this video. Please like and subscribe.